Good morning, and it's my pleasure to talk to you today about energy and energy analysis, ways we can find ways to save money. This presentation is being video recorded at this time. Energy costs are between 20 and 30% of the total mining costs for operations. Therefore, it is a target-rich environment for cost control and cost savings. I'm going to go through a quick review of some of the topics I'm going to talk about today, from fuel analysis to opportunity costs of no power at the mine, to backup power, how we structure our power contracts, energy efficiency, and then finally, renewable energy. What's the first thing we evaluate when we look at a new mine site and we're looking for power supply? Do you look at site? Do you look at EPC contractors? Does fuel find its way to the top of the list? If it doesn't, it really should, because fuel costs are 65 to 85% of the 20-year life cycle costs of power generation. Perhaps we should spend a little more time on fuel for our selection. With a clear focus on fuel, we can then ensure that our mine has both reliable power and reasonably priced power. Especially in developing countries where the supply of fuel as your primary supply may not always be available. You need to also investigate a secondary fuel, perhaps secondary fuels. It's better to have a plan B and a plan C in your hip pocket. Because the reality is your primary source may not always be available. Another point about selection process, yes, we do like to have the highest efficiency of our power generator, but in those areas in developing countries, it's more important to have a generator that can accept multiple fuels, and not only accept, but can switch from the plan A fuel to a plan B or a plan C fuel. So let's go over our fuel supply checklist, things that we should be concerned with when we look at our fuel. Oh, thank you. Oops. So what are the things that can go wrong with fuel getting into the country, through the infrastructure, to our power generator, either at our mine site or on the grid? What things can go wrong? Looking at how fuel is delivered to our power generator is so key. In fact, looking at all the elements of that delivery supply chain to make sure we have adequate capacity from point A to the end result. Is there infrastructure and capacity not only for the primary fuel, but for the plan B and plan C fuel? Is there adequate capacity to get it to our generator? And finally, can the generator switch fuels from the primary to the secondary easily? Because that is the reality in a lot of developing countries. In developing countries, issues with fuel, power generation reliability, and utility solvency are so important to ensure a reliable supply of energy for our mine. And by utility and solvency, I'm really talking about this one question: does the host government always pay its fuel bills to ensure reliable fuel gets to a generator to be able to generate power consistently and reliably? Rather than believe a government's claim that power supply will be available for our mine, we need to analyze an independent energy supply demand study to ensure that all the key components are there for a reliable power supply to our mine. There's several components to the supply demand. including a capacity utilization of the generators that are in that country supplying power to the grid. How many hours a year do they operate? Is it 50%, 80%? That's key points to know to ensure that the mine will have power throughout the entire year. Is maintenance done on a routine and a reliable fashion to make sure that we have the highest generator capacity utilization rate to ensure more reliability for our mine? And once we know the energy generation system is likely to perform, and we've modeled it, the supply demand, we can estimate what potential risk of a load curtailment or a load shedding event that can affect the power supply to our mine. And from that, we can design our own power loss mitigation plan. So let's look at the opportunity costs of no power to the mine. Once we know the gaps in our mine's energy supply-demand balance, what are the problems that can go wrong, we can determine what that gap costs us. Opportunity costs at mine sites could be anywhere from $25,000 to $40,000 an hour. So you want to minimize the unplanned downtimes. The opportunity cost has three components: lack of production of your revenue generating product, whether it be gold or other minerals. Once the mine is down, it's not producing revenue. The second factor is idling the mill. Even though you're not producing revenue, there are fixed costs such as labor that continue to go on whether that mine is operating or not. And finally, the backup generators. For certain critical loads that must have power, when your power supply from the grid is down, those generators kick on, adding additional expense to your mine with an unplanned power outage. So we need to determine what those opportunity costs are available for our mine. And from that, once we know that cost, that's basically our pot of gold of money that we can use to fund our power loss mitigation plan. Opportunity costs and backup power are related. Remember, generating power on site with diesel engines is very expensive. Remember, 65 to 85% of the 20-year life cycle cost is fuel. However, unless the mine is off-grid and you're wedded to that on-site generation, having backup generation and the CapEx to install that is only about 5 to 10% of that 20-year life cycle cost. So in this context, we need to view backup power as an insurance policy to hedge against events where we have an unplanned, unscheduled, and short-term power outage from the grid. The amount of backup generators we employ at our mine site is to cover any shortfalls, short-term unplanned outages. And for those generators that we install, if we install one additional generator to allow for maintenance of a backup generator or an unplanned generator outage, we'll get about 94% reliability. If we add 2 additional generators, we get that reliability factor approaching 100%. Have we looked at the power contracts that dictate what our price of energy at our mine is going to be? Have we analyzed the rate structure and the penalties that are imposed for certain behavior in buying power? These are ways and windows of opportunities for power cost savings and power projects. I think a key to understanding power contracts and power costs are breaking it down into the three components of our power bill. The energy costs in cents per kilowatt hour. The demand charge, what's our peak demand in kilowatts at any moment during that month? We get penalized for that if that spikes upward. And finally, we pay for a power factor charge, reflecting the power quality of our mine's power receipts. Some other things that we need to know: how much power does our mine use? When does the mine use its power? Is it ongoing 24/7, or are there spikes in that demand in kilowatts that we pay dearly for as we reserve capacity by the utility to supply that peak power to us? By dissecting the bill, we can generate energy cost-saving projects that can make real bottom-line economic impact to our mine's balance sheet. So what are the key energy bill questions we ought to be asking? Because right now, we're prospecting for energy cost savings for our mine. What are the tariff charges of our power bill? And what's the impact of each one of those on our bill? How does the mine's power demand in each of the 8,760 hours each year compare with our rate structure provided by the utility, and also the penalties in that rate structure given to us by the utility? I think it's really key to remember that how much and when we use power at our mine site provides this opportunity to save power costs and reduce our operating costs for our mine. Energy efficiency. Let's shift a little bit from the energy supply side to the energy demand side, how we use energy at the mine. What improvements can we make at our mine to use less energy in kWh, kilowatt hours, less peak demand in kilowatts, which we pay a demand charge for? Because knowing those two items, we can save real money on our power bill for the mine. Another help in energy efficiency is to look at the efficiency of our lighting, our pumps, our fans, our motors, the key and primary power hogs, power demand at our mine site. And for the haul trucks and those sites that generate power consistently from diesel generators on site, we need to look at fuel efficiency, because technology today offers us the opportunity to reduce that fuel consumption by 3 to 5% or more. Not only fuel consumption, but fuel costs and also fuel emissions. Looking at our fuel, how we use it, reducing the uncombusted hydrocarbons in the diesel can be solved by adding oxygenates, detergency, and lubricity to our diesel fuel to get more value for our diesel expenditures. As we frame energy projects and cost savings, it all starts with vetting both the investment that we need and documenting the potential savings that our project can yield. We need precise calculations of energy consumption savings and what that means to our demand of power at our mine site. Once we have these in hand, we can evaluate the capital requirements and also compare that with our cost savings. These cost savings are, for a project capital, is the energy revenue stream that balances our capital investment. Once a compelling and operational improvement analysis has been done, we sell management on an energy cost-saving projects by showing them the money to paraphrase from the movie Jerry Maguire. Renewable energy has its place at the energy table in all areas of industry, but especially in mining. Areas that are remote, that are off the grid, offer the opportunity for renewable energy, solar, wind, hydro, and also can help be supplemental energy for those operations that are a 24/7 operation, milling and producing revenue. But first, we need to know how we use energy at our mill, as in the capacity factor. How many hours of the year? Is it 8,000 of the 8760 hours that we use it? Or is it 4,000? What type of operation do we have? Then we compare the price of energy that we pay for with the price that we can generate with solar, wind, or hydro. This is the key starting point for an energy project to be born. How much energy renewables can generate through a resource assessment? We compare that with the capital that is required to put that solar, wind, or hydro facility in place. For 24/7 operations at mines, renewables are not going to handle all 100% of the energy requirements, but they can be an ancillary alternative for a portion of the energy, especially if the alternative is higher priced diesel generated on site. It could be very cost competitive. Renewables must help the mine by either reducing costs while not interfering with the power reliability to the mine. So let's go through the top 10 energy questions. Just like a Tonight Show with David Letterman, I had to have a top 10 list, so you're hopefully going to enjoy this. But we want to look at ways to reduce energy consumption, energy costs, and energy emissions. So with energy 20 to 30% of the mine's total cost, are we really engaged sufficiently to look at ways that we can reduce our energy costs? Number 2, energy analysis, cost savings. It all starts with the raw data. Do we have raw data of how we use the energy, when we use it, and what's the cost of our energy? Number 3, we can only improve what we monitor and measure. It's a simple fact of business life. Are we monitoring and measuring our energy use, our energy costs? And once we've vetted an energy project, what is the savings in kilowatt hours of energy, kilowatts of demand, BTUs of natural gas, and dollars? This forms the basis for a profitable energy project. And 5, do we know the range of savings that we could potentially get from an energy project analysis? Moving to the last 5, with so much concern for mine economics and the environmental impact, do we know our carbon footprint of energy use, diesel fuel consumption for haul trucks, and or on-site diesel generation for power? What is our environmental stewardship record? Number 7, since renewables have a place at the energy table at mine sites, what are the energy resources that are available to us, such as solar, wind, biomass, hydro, etc.? What are its CapEx? What are the savings that we can glean? Number 8, have we evaluated our risk of no power, should that happen? What are the opportunity costs, and how does that impact our operations? Number 9, how do we limit process downtime by hedging our bets with an adequate amount of backup power so we can operate when we want to? And how are we lowering our power costs, power use and power costs? Do we have experts such as a certified energy manager to dig through the energy data and prospect for the goal that we'll call today energy cost savings? So in summary, there's 5 keys. Fuel analysis is so important. Remember, with so much diesel fuel used for either haul trucks or generating power, getting the right fuel source efficiently doing the work is a real key priority. If you only remember one thing from this presentation, for power generation, 65 to 85% of your 20-year life cycle cost is the cost of your fuel. Relying on an independent energy supply demand analysis of whether energy supply will be available for your mine is so key. It's the only assured way of making sure that we have reliable power to our mine site every hour of the year. Our mine's energy reliability and that supply is counting on this type of analysis. By understanding our opportunity cost of no power, we can generate a proper energy mitigation program. And if we don't understand the timing of power, it's difficult to devise strategies to save money. And then on-site backup generation is relatively a low-cost insurance policy. My contact information is shown. I've got some business cards up here. I'll be presenting improving diesel quality to reduce costs and emissions next door at 11:05 today. So I'll leave for that presentation. But I am available for any questions that you may have right now.